Hi, everyone. Welcome to the TriStar webcast. My name is Thiagu Palaniappan. Today's topic is going to be on the Creo Simulation Live product, a true simulation-driven design. We want to go over that in the next 45 minutes or so. Before we get started, a few things here from the logistics standpoint on this meeting. All of you will be muted during the presentation. If you have any questions, please start typing in your questions in the questions area, and I'll try my best to answer them as much as I can towards the end of the presentation. There's also a handout section. If you could please download that and view it during the presentation or after. It has a little ebook around Creo Simulation Live product. Okay. So with that, thanks for joining. And those who are not familiar with TriStar, we have been in business for over 25 years here, and we are experts in CAD, data management, PLM, product development, and we also have some custom solutions. We are the largest reseller worldwide for PTC products. We are headquartered in Phoenix, Arizona, and we do have our team spread in the United States as well as Canada. So it's a quick overview about our company. We do, training, consulting on PTC products like Creo, Windchill, right, implementation, best practices, etc., on the various PTC products there. As for some of the time-limited offers here, before I get to the agenda, if you're interested in in simulation, we do have a time-limited offer running through the end of this year, 33% off on the different Creo simulation products and extensions. If you want to know more about these, please visit our website or reach out to your account reps to get more information about these time-limited offers running this quarter. Now, as for the agenda, some of you may have, be using simulation tools like a high-end analysis tool, and some of you may not be using simulation tools, and some of you mainly have a role of a designer or an engineer. But PTC partnered with ANSYS about a year ago, 2019, actually, but more than a year ago here. And then they integrated the ANSYS technology inside Creo Parametric, and they were calling it Creo Simulation Live. So I wanted to go over some of the simulation-driven design challenges we have with the existing current product development process that many of our companies use, and then how Creo Simulation helps with that process to make it a truly simulation-driven design process. We'll go over the capabilities, show you some examples in the time we have here, and also go over some hardware requirements, and also wrap it up with the Q&A session towards the end, where you can start typing in your questions in the questions area. Okay. So this is something that all companies that we consult with, or over my years, we have always seen, right? Product development companies and teams, right? Whether they're trying to achieve is improvements in these areas, right? So deeper understanding of how their product performs, right? Shorter development cycles and quicker time to market, right? And then, if you think about fewer prototypes, right? First time quality at reasonable cost, and also reduced warranty and liability and exposure. So these are the things that I'm sure all of you are aware of, that pretty much all product development companies are striving to achieve, right? So let's look at how we could achieve this using a true simulation-driven design process. But before we do that, let's take a look at a typical product development process and where we could potentially have a genuine improvement, right? So I'm sure those are all of you that are watching. You're probably familiar with this depiction of a traditional product development process, right? So for many years, right, myself, I've been in the industry for a good part of my career, and the industry has tried to consistently use simulation as part of the design process, right? They always try to do that, but the reason is, we just talked about in the previous slide, just to achieve, that's the main reason we have been trying it. But unfortunately, the fact remains that when simulation is used as part of the product development process, it's used almost exactly as you see in the slide that I show here, right? It's very much used as a final validation step after the design is practically complete, right? And that's not the exact vision of simulation-driven design, right? I would argue that's not the exact vision of it, right? We always do it as a final validation step, and why is this? Why are we? What is the main reason? What are the barriers, right? Currently, to do a true simulation-driven design, right? If you think about it, it's quite a few. I wanted to list out some of these, right? Very often, engineers feel like they don't have the experience they need to do the simulation while they design, right? They feel like they have to consult an expert or outsource it to an FEA consulting company, right? That is one of the barriers, obviously, right? And then, if you look at the actual design model itself, right? They may have to defeature it. Some of you that have done finite element analysis, the traditional finite element analysis, the process, right? If I would, regardless of the complexity of the part or the assembly or the design, you will have to defeature it so you make it analysis ready, right? Many times we would have to spend some time, getting rid of unwanted features, so that the mesh size gets lesser, so computationally it becomes less expensive. So it's almost like you make a copy of it or do a save as, and then you go from there, right? And typically engineers don't feel comfortable making that judgment, right, when they are working with even these copies. And also design itself, as we all know, is an iterative process. So as you are doing the simulation, there are some changes being done on the design side, and there's going to be multiple versions, and it's just not efficient, and it's just too disruptive, wherein you'll have to go, if you take the role of a design engineer, to go to each one of those and run a simulation. It's just not feasible, right, in the real world. So that's kind of why PTC, is trying to solve that problem by partnering with ANSYS. And in 2019, PTC partnered with ANSYS, and just to make sure that they get the ANSYS technology inside of Creo fully integrated. And the goal is to not make it very complex or for high fidelity solutions. It's mainly for design engineers to quickly get instant feedback and do true simulation-driven design. That's the main reason here, right? So they are kind of removing the barrier between computer-aided design and computer-aided engineering, right? So computer-aided engineering being more of a specialized field so far, but they want to, that line's getting blurred as we see more and more design engineers wanting to get some more of a guidance or some directional tool that will tell them if they are going the right direction, right? So before they might even send it to a high-end analysis or an expert, right? It might be very useful. So that's the goal here for the designer to do some upfront analysis, and that is the main reason for this partnership. And I'm sure all of you know PTC has been here for nearly 30 years, and then ANSYS over 48 years, 45 plus years of simulation experience. So it's like both the leaders coming together to create this product called Creo Simulation Live, right? That's fully integrated into Creo Parametric. So going back to the true simulation-driven design, right? Where so imagine if you could do a simulation and get real-time instant feedback. You're not spending time on pre-processing, you're not spending time on running the analysis. As you design, as you are in your work in progress state of your design, you would like to have more of a directional tool that's telling you, guiding you in the design environment. You're not even switching applications or going from one application to another application. It's just the same environment where you have your analysis telling you about the maximum stress, or the deformation, or the temperature, or the frequency, the modal analysis, right? All those types of analysis supported. So it'll be nice to get some instant feedback as you're still in that first stage, right? Rather than as a final validation step, it'll be nice to have that initial guidance, right? So instantaneous feedback, right? And then what if scenarios, right? I'd like to make changes to the design instead of Creo Parametric, and I shouldn't be rerunning the analysis. I would like to have instant feedback to see if those changes did impact the performance of the design. So that's what I would say is a true simulation-driven design process. And again, you can control, speed versus fidelity. There are options inside of Creo Simulation Live. There's a way to say that we want more accurate solution or more speed. And this tool, again, like I said, is mainly meant for designers or engineers that would like to get quick feedback as they're designing their parts, right? They don't have to have experience in an FEA or in traditional FEA software, right? So it'll also help them do these type of upfront FEA really quickly, rather than sending it to an analyst or an expert. That can still be done for very high fidelity nonlinear analysis, but that still has a place for the analyst. But this is mainly for the design engineer that is using the CAD tool, which is Creo Parametric. It's fully integrated in there. Okay, so I'll show you some examples as we go here. Now, so what exactly is Creo Simulation Live? It is ANSYS technology working inside of Creo. It gives you real-time feedback and results on structural, thermal, modal, and with Creo 7 fluid simulation, right? So the goal here is to give you better designs using real-time feedback. There's not even a run or a solve button. You pretty much look at the results once you set up your model instantaneously. When I keep saying instant feedback, real-time analysis results, what is going on behind the scenes is it's leveraging your graphics card's GPU instead of the traditional CPU, right? So that's very important. That's kind of how you get that instant computation and visual experience using GPU technology. So it's ANSYS came out with a product called ANSYS Discovery about 2-3 years ago, and that's what is running inside of Creo Parametric, and it's fully integrated, and it's called Creo Simulation Live. Okay, and it's also available starting Creo 4.0 MO90 date code. So it's available if you're on Creo 4, 5, 6, or 7. You should be able to use it with that license, right? We'll also talk about a little bit on the couple of license options we have for Creo Simulation Live. And then, so really quickly here, just to give you some of the key, benefits of why you would use Creo Simulation Live is the speed. That's one of the biggest ones. I'll show you some examples, and you'll see the speed with which you're getting instant feedback. It's literally running it in minutes or seconds, regardless of the complexity of the assembly or a part. And you're able to make quick edits to the geometry, your regular Creo edits or creating features, and you're going to get immediate feedback. You could also have the results displayed while in the modeling environment. So you're just in your regular Creo design mode, part mode, or assembly mode, or sheet metal mode, what have you, but you're able to get that instant feedback, right? And again, it's based on the golden standard by ANSYS, right? I mean, it's proven technology. We know they've been in doing analysis for a long time now. So you also get that confidence of accuracy there on linear structural analysis, thermal, modal, and basic fluid flow analysis there, right? So those structural, thermal, and modal were made available starting Creo 4.0, but in Creo 7.0, they have a new license for the fluids, and they have CSL Fluids or Creo Simulation Live fluid capability as well. Okay, so that's a new enhancement. I was talking about that, right, just here, wherein you can not only create structural, thermal, and modal analysis, you can do external flow, internal flow. The fluid domain creation is automatic, right? So when you do any type of CFD software, you always need to create that fluid domain, right? It could be internal or it could be external, right? For internal flow or external flow, that fluid domain is critical, and that is automated inside of Creo. I'll go through some examples, and then you can assign your boundary conditions. You can assign your your inlet velocity, inlet pressure, outlet pressure, mass flow rate, etc. And then you can visualize, as you can see in some of these images, the streamlines, the change in the velocity, right? The direction field, the particles, etc. Right? It gives you basic fluids, cutting planes, a lot of options for results, and it's also instantaneous since it's using again GPU technology instead of the traditional CPU. Okay. Before I show you some examples, just real quick here on the different license options in order to use this. Creo Simulation Live has two options. One is Creo Simulation Live license, and the other one is Live Plus. The Live kind of gives you the structural, thermal, modal capability for fluids, which works only starting Creo 7. Fluids will work. If you're in an earlier release, you will have to you can still use structural, thermal, and modal analysis, and the results displays available on with both licenses. So there are really two license options. There is also a trial. If you are in Creo 5030 and later, you're able to just access a built-in trial if you would like to test it out before getting this license there. Okay. Now, as for the hardware itself, Creo, PTC they have a hardware check utility just to check if your NVIDIA CUDA-based graphics card it does support Simulation Live or not. It'll do a quick hardware check like this. It'll tell you that it is valid, right? So you need a minimum of 4 GB. I'm talking about the video RAM on that graphics card. That's important. So here are some couple of examples here, but the recommendation is to have 8 GB, but 4 GB of video RAM is required, and it has to be an NVIDIA CUDA-based graphics card, right? And PTC, if you go to ptc.com, in the support page, they have more information of around the supported graphics cards specific to Creo Simulation Live. So here are a few examples of the Quadro cards that are supported, right? The video RAM being the key here because it's leveraging the GPU. Okay. So with that said, let me show you a quick example here. So I want to take let's say I'm an engineer or a designer that may not have any experience in finite element analysis or structural analysis softwares, and I'm going to model. I'm going to open an assembly here where I'm in my design process, like I explained earlier. I might be working on this assembly where I need to work on this support bracket, if you will, right, on this subassembly, right? That's what I'm tasked with. And as I'm working on this, it'll be nice to have some guidance or direction as to, what about the stresses and the deflection if I were to go with this kind of a design. So the part is just done with a couple of extrudes here right now, and then I'm still in the process of evaluating as to what type of geometry I might want in between, right? So right now I'm just in my Creo Parametric design environment here, and I do have a sketch here that I might want to have activated the part, and I might want to extrude that, and I'm going to say let's extrude it to this surface, and I'm going to go to side 2, and I'm also going to go extrude it up to the surface, right? So far, so it looks like I've created a very simple design here. It's not even completed yet. I've not added the fillets and all the details, but at this point of time, where I'm still in the process of working on my design, would it be nice to, quickly, use live simulation to tell me if this is okay, or should I be using a different shape, right? What would happen to my stress if I were to go with this? So I could do it in part level or assembly level. First, I'll show you part level, but I could just go to live simulation. So I'm not even accessing another application. I'm just going into live simulation here, right? So when I go into live simulation, right now it's loading the ANSYS libraries and everything, right? So it's and it's loaded, and all you get is pretty straightforward here. You could do a structural, thermal, modal, or a fluid flow analysis, right? There are 4 types of studies that you can do since I'm on Creo 7, right? And of course, you have your constraints, your loads, and there's not a run button or a solve or a mesh button here, as you can see. All I see is simulate results. That's it, just results probing and simulation report. This is all tells you it's going to be instantaneous, right? So I have my part done here, and I'm going to just go fix the bottom here, for example, right? We'll just fix that. We'll apply maybe a specific load in here. I'm going to say I want to apply about, let's see here. You can apply it in any unit system, as you can see here, that you're comfortable with. I'm going to just assign in the negative direction here about 100 pounds. And the material is assigned, right? I have, assigned from my Creo library, where the steel is what is assigned. And all I do is I hit this simulate show results button. And what the system is doing right now is it's leveraging the GPU of my graphics card, and in seconds, I get the instant feedback. I didn't have to mesh it. I didn't have to run the analysis. I didn't have to do, any type of pre-processing. It just gives me instant feedback here, right? Now, if I do my deformations, right, I'm looking at my deformation, have some results option here, right? Maybe I want to look the von Mises stress here. Where's the minimum maximum? It kind of tells me where the minimum maximum is right here. That's where the maximum it looks like is. And it shows right now it's about 15 megapascal, as you can see. That's the current stress. Now I'm thinking I can just go back to the model mode. See, I'm not switching any type of application here. I'm in my regular design environment. You can see my Creo design features, my model tree. I'm still able to see the results. And I'm thinking, instead of this design, if I go redefine this, immediately that analysis is gone, but I can go switch to a different shape. So maybe I'm thinking, instead of that shape, what if I use this shape, right? And as soon as I'm done with it, I'm not even having to rerun an analysis. It gives me immediate feedback. And now you know why we call it Creo Simulation Live, right? Instant feedback. And look at that. And the maximum stress is increased about 60 megapascals now compared to 15. So I'm thinking, okay, this may not be a good path, right? So it's more giving me direction in here, guidance as I'm designing. So I'm going to go say, okay, let's use a different shape here. I just have a few external sketches, as you can see, and I'm redefining my extrude. And each time, as soon as I'm done with the redefinition of that extrude to point to a different sketch, I get instant feedback telling that, okay, the maximum stress now is 17 megapascal, right? I can always go back, redefine it, and say, let's try with this shape instead, right? It's almost like I'm in my ideation or design exploration stage right in here. At that time, rather than sending it to an analyst and waiting for him, he might already be a very busy guy with a lot of analysis work that he's doing, high-end, high-fidelity analysis. I just want something very quick that's guiding me here, and that's really what it's telling. So it looks like, again, it's gone back up. So I'm thinking maybe I should just I'm just redefining it and use the original shape, and that looked like 15 was the least stress with this one, but still I'd like to improve, right? So if you, as a designer and engineer, if I'm going to show this, the next question is, okay, you do have a high stress there, how are we going to improve it, right? The what if scenarios. So it looks like it's about 15 megapascal. How about just throwing in a round in that corner right there? I'll add a fillet in there, right? I'm added a fillet in there. Let's see what happens. As soon as I'm done creating that feature, I get instant feedback, right? I'm even not having to even switch any tab, because the simulation is always on. The results are always on. You can also toggle it off if you'd like, but I'm in a design environment, and this is that's why I call this a true, simulation-driven design, where it's almost like giving the ANSYS technology to the design engineer as he's working on it, instead of Creo, and you can still leverage Creo's parametric editing and feature creation capability, and you get instant feedback, right? Looks like I got it down a little bit, right? From 15 to 12, but I'm still not happy with it, right? I might want to go and see there's some high stress here too, it looks like, and let's add maybe a chamfer in here. I'm going to add a quick chamfer. Let's see here. I'm just going to add. And every time I add material or remove material or I make any change, I'm getting instant feedback, right? I'm just, the GPU is kicking in and gives me some instant feedback. It looks like it didn't change a lot this time. And I'm thinking maybe we might have to add some, as an engineer, when you design these, you might think, okay, let's add some ribs to support it better, right? So let's help, hopefully that's going to help. And so I'm going to add maybe, let's say I'm going to do a quick profile rib in here. Let's see, I'm going to collect some of these references in here as I'm doing this. And I'm just going to say, let's add a quick rib. There it is, give it a specific thickness. And instantly that rib, with that rib included, it tells me, okay, the maximum stress now is gone up because you have a sharp corner there, right? Now I'm thinking, okay, so how about maybe let's go pattern this, right? Maybe we'll just go pattern it, use a direction pattern, right? Creo 7 has all the interface, everything in the mini toolbar. So I'm going to go into this direction pattern and say I want to have about 3 of them right in here. There it goes. And when I'm done with this, again, I'm looking at my results here. Instantly tells me, okay, from 15 megapascal, it has come down, obviously. And now I'm thinking maybe if I could just, maybe increase the length of it, it's going to hopefully help there. And so it's more like initial instant feedback is huge, I think. And it's now I've got it down, almost, I mean, it used to be 15 megapascal before, and now I've got it like around 7 megapascal, which is good. So let's say I might decide to go with this design, or I can even add some additional probes in here. So for example, I could go into live simulation and I could add some simulation probes. For example, I want to go maximum, and I want to just go to the part, right? The entire part. What is the maximum von Mises stress? I could save that out, as you can see here, right? I can also go to my query and accumulate the data if there is any history, right, of the different design points, right? This is the first design point that I have. And I could just go and keep making any additional different changes now, still keep improving it. And this is like a measure, like a parameter that I could keep looking at as I make my changes there, okay? So now, similar to this, I should be able to also go and into the part mode. Right now that I know it works in assembly mode. I know it works in the part mode. Now that I know this is a good, this is what I'm going to go forward with, I might want to mirror this component off of my an assembly plane here, and I just created another one on the other side. Quickly did a mirror of the component, so I'm just back in my regular day-to-day Creo assembly part modeling design activities is what I'm doing right now, right? And I'm thinking, okay, it would be nice to check on this entire assembly. I know it's got a lot of geometry here. I don't want to spend time defeaturing, removing the model, cutting the model in half, etc. I just wanted to have a quick idea of on an assembly like this, could I use live simulation? It worked great on a simple part, but what about an assembly like this? Same thing, I can go to live simulation and I can just go, let's say I want to fully fix this bottom surface here and maybe assign a specific load, right? I want to just go with a specific force load. And let's see here, I'm looking at my triad here. It's my Z and Y direction. So maybe I'm going to apply about a negative value here, and then Z will give it 100. So it has the result is at least roughly around like 45 degrees here. So that's the load I've given. And again, as long as all the parts have materials assigned, I'm just able to go hit the live simulation. And when I do that, as you can see with the assembly, it takes a few more seconds compared to the part. But the nice thing is it's going to come up quite relatively quickly here, just like it did for the part. It didn't take, it was like less than a minute obviously there, but there it goes, right? I'll have to let the results kind of settle in there as it's working on it right there. And now it tells me that it's about 8.5 megapascal on the entire assembly, right? Again, the assumption here is they're all bonded and we're not looking at any type of contact nonlinear analysis. And this is not the tool for that. If you want to do high-end nonlinear analysis, yeah, there are other solutions, but this is mainly meant to give you an idea about the overall this linear type analysis, simple ones here. You're not spending time meshing it. Everything is behind the scenes here. and it's just using your graphics card's GPU, right? There's your deformation, there's your stress plot. Now, I can also do multiple analysis here. So there's structure one. I could just go add another structural analysis. I could do different studies in here. For example, as I'm working on this, I'm thinking, could I just leverage that part level FEA in the assembly level, right? I can absolutely do that. I can define something called scope while in assembly, where I could say, let's just, even though I have the entire assembly, let's just look at this part, right? That's what I've defined as my scope in there. And I'm able to go either define a new study, right? Or I can import existing simulation studies from a lower level part or subassembly. So I'm going to go and say, let's just select this component, and there comes your analysis that I had done at the part level. I'm including that right in there, right? And there it is. So if you look the loads and the constraints and everything right there, it has a scope defined, right? Or I could just and in this, let's activate this one. I did a new analysis here, and here let's define the scope to be, there's the only thing that needs to be scoped. I don't worry about the rest of the assembly there. And if I do a live simulation, you could see how you're able to, I can also hide the simulation display here, but you're able to look at the assembly, but instead of creating a simplified rep or getting rid of components, etc., I'm able to scope. So that I really like how you're able to just select components that you're interested in. It could be more than one component, but it'll just show the results for that alone there, right? So that's so you can have different analysis. It doesn't create any type of output files or anything, right? All you're doing is you can, of course, get a simulation report, right? An HTML report. That's pretty much it. You're not really, creating any solution folder with multiple files to manage or solution files, because it's instantaneous, right? Every time you save this assembly, it has the loads and constraints and everything. You just hit show results. It's just a matter of showing that. And there's your report, simple report with all the key things that you might be interested in, like von Mises stress, principal stress, maximum deformation, etc., including a picture and some information about the model. That's it, right? And if I can go back to my model mode, I can hide those results, and I'm back in my design environment, and that's why I call it the true simulation-driven design process here with Creo Simulation Live, right? So that's on the structural side. Just to show you a few examples on the other types of analysis we could do with Creo Simulation Live is, let's say I open up this valve cover, right, design, and I'm planning to use live simulation to know the natural frequency and the mode shapes. I would like to know the modal analysis, right? Maybe this fits onto another system or a component that is subject to some kind of a vibration. So I would like to know the natural frequency and the mode shapes, obviously, right? And currently I have a couple of material options here, right? I could be using either ABS or aluminum, right? I have a couple of options there. So I'm going to set ABS as my active material, and I'm going to do a modal analysis right in here. So when I do the modal analysis, again, all I have to do is just, constrain. Let's have it fixed in here. And I do play simulation right here. Just show me the results for the modal. It already has a material, so it should have the mass properties, the shape, the geometries there, and there it goes. It tells me mode 1. So I just have to allow it to settle in there a little bit. You can see the solution is it's 280. It's right around 280, 286 in mode 1. If I look at other one, right, there is mode 2, there's mode 3, mode 4, etc. Right? There are different modes. Or I can go to my simulation report, and just like that on that component, it's telling me, there it is, right? It has the different modes. I could allow it to, just wait a few seconds here so that it's updating all these. I can also look at the mode shapes, right? I can just go to animate, and that's mode 1. That's mode 2. You can look at the mode shapes too, right? Mode 3, etc. So the modal analysis is very useful, I think. It's almost like you're in a discovery phase of your design, and you're not having to spend a lot of time pre-processing, going to an application. You're just in your design environment, and you're getting quick feedback here. Now, right now with mode 1, with this material, I'm getting 279 Hertz, but I'm thinking what will happen if I switch the material from ABS to aluminum. I can just right mouse click on that and say, let's reassign. As soon as I change the material, see what happens. It goes back to the blue where it's starting to solve again, and it's telling me, okay, with this material, and as you can see, it's starting to, the frequency seems to be hovering around, you know, you can see there right around 900, 940. It's still kind of settling in there, right? As you can see here. So now if you see the mode 1, mode 2, mode 3, mode 4, it's going to have a different value. So it's not just for structural analysis. You can also use it for doing modal analysis here. Of course, I can stop the analysis, get back to my design, and do some additional changes. And you'll see immediate change in those results. I can toggle them on and off anytime here, right? It's just a simulate turn on and off option there. Similarly, if I could also do like thermal analysis, for example, if I go to an assembly like this, right? If I go and do live simulations, I already set up a few things here, right? I got a boundary condition, right? If I turn on my display here, so convection boundary conditions, initial temperature, right? Heat loads for these chips, right? I've assigned different heat loads for those, you know, chips in there, some heat loads there. I could assign maybe, as you can see, it's pretty straightforward. You apply your scope, your temperature and convection conditions, heat flow, heat flux, and you look at the results, right? So if I look at convection, let's see here, I'm just going to go select a few surfaces that I would like, you know, to assign a convection heat transfer coefficient here. So let's say we'll apply a specific, and then we'll apply an ambient temperature of 30, and that's pretty much it. And I hit the play button. And what it's doing right now is it's trying to solve, again, for this assembly. You know, it's giving you, and I know it's right now, it's giving me instant feedback. But if I want to have higher accuracy, I have a little, there's a performance option here where I could instruct Creo Simulation Live to use the maximum GPU, right? I could just bump up the accuracy all the way to the right, and it's going to take a little more time, as you can see here, compared to before. It's still right now blue, and you can see that I'm getting, you know, the maximum temperature here now. It's kind of showing hovering around 259 and 230, you know, right there. And you know, so, or you can just, the default is, you know, in here just for the demo, I've just left it to speed in there. But in the real world, when you're doing it, you could always slide it all the way right. So you have a little slider that essentially controls the accuracy versus speed, right? So you can play with that too when you use the software. So now the last one I wanted to quickly show is the fluid flow, right? Just so we talked about how it's helpful for structural, thermal, and modal, and all these are available starting Creo 4.0 MO90, right? Now I have a license, and you will have a little simulation live trial, and you can try that out. But if you have Creo 7, they also have started including thermal, or I'm sorry, fluids in there. So very basic ones in here. So for example, if I let's see here, if I can open up an existing design, I'm going to open up it can literally create your let me just go to thermal mixture here. There it is, right? So something that is not set up here, just to show you how the fluid volume also is automated, right? So I have the thermal mixture here. I'd like to have, let's say, water or again, assign a material. But before we do any of those, whenever you do a fluid study, I'm going to start with a fluid simulation study here. It needs the fluid domain, right? If you have an existing domain, you can just select it. But here I'm going to go do an internal volume. And all I am doing is I'm selecting my boundaries here, right? I'm just selecting these 3 surfaces, and it's, like I said, it's automated. It knows to select the inside. It knows to pick gives you the fluid volume automatically. And there are a few options here, right? It could fill holes and a few additional options, but all it's doing is the boundary and the seed surface. It selected that, and it is we have got the fluid volume. Now that we have the fluid volume, I could just go edit material, and I can assign, you know, air, carbon dioxide, engine oil, mercury, water vapor. I could even create new materials, but those are the materials that comes by default and say I want to assign, material as water for that. Just go water for this fluid volume. Now all I have to do is pretty much, this, I could assign a flow velocity right in there. So let's see here. I want to go in the X direction. We'll just say I want to go direction and magnitude, and you can just give it maybe I'll just select meter per second here. Just give it about so much meter per second. Just going to go similarly assign a velocity here. Also in the Y direction, let's say about specific velocity here. There it is. I can look at my simulation just to make sure that's a velocity, and outlet pressure, we'll just give it 0 for the outlet pressure. So here, again, I'm using the mini toolbar. It's all available on just like in your regular design mode. There it is. So I've assigned the material, I've assigned these boundary conditions, and I can also go ahead and specify some temperature if I want, right? I could just say, okay, so this is supposed to be, let's see here, we'll just go specify about 40 degrees. We'll just say the temperature here is going to be about 120. There it goes. And now if I go, I'm just going to go hit the live simulation, and you get immediate feedback, right? So that's the key here, right? And it's a transient analysis, obviously. All fluid solution studies inside of Simulation Live is transient. You can see the seconds there as I'm allowing it to just run in there. And then if I go to the cutting plane, I can look at a direction field, right? I could look at streamlines, I could look at particles, right? So it's all, again, so many options there you can control all that. Very useful, I think. And you can make changes to it. So for example, I could change the temperature, I could change the diameter, and I'll see it update in real time. I can pause the animation and everything and see what's going on, right? Or just completely turn off the results itself, right? Similar to this, right? This is you can do external flow as well. For example, like I might want, if I go to one of these assemblies here, I might have, let's go to live simulation, and if I go do a new fluid study, just like we did the internal volume, you could also do the enclosure volume, right? So there's an enclosure volume option there. So when I go to enclosure volume, I'm just specifying my my volume here. It's automatically transparent, and I'm just specifying some boundaries for that box, for that volume, for the enclosure volume here. We'll just give it a specific volume, and as you can see, it's automatically set to transparency. I can assign a velocity here. So for example, let's see here, we'll just give it specific velocity here. We'll give it also for the slip symmetry, because we want, to understand that is going to be the walls of it. So we'll just give it so it can flow through that, or at least along it, no friction there. So there it is. And I'm going to just specify a pressure of 0 here, and that's pretty much it, right? So of course I have to assign my material, right? We'll just give it air this time, and I hit the simulation tool there, or show results, and just like, just similar to a structural analysis or modal or thermal, you could see that instant feedback, right? I've been in the industry for a long time now. I've used all the Creo Simulate, Mechanica, and many of the traditional FEA tools. I used to be an analyst during my days, but this is impressive as to how quick you're getting the feedback. And I understand it's not very high-end, high-fidelity analysis. There is still a place for those, but it's nice to see how they're kind of, the goal here is to democratize simulation to the engineers and the designers, right? Where they may not have experience in FEA, but they'd still like a quick feedback, right? That's really what we are looking at here. And now this is looking at velocity. I could look at pressure, temperature, things like that. I can also look at streamlines here. So maybe remove the cutting plane, and I'm looking at the streamline. I can go and you know, change. It's like an emitter pretty much here, right? And now again, you know, for the turbulence on this side, or even in here, right? Maybe I can just go and as the system is giving me some feedback here, I have a few components that I've suppressed, as you can see here, right? The roof fairing, the side fairing. I can just say, okay, what happens if I resume that? So there it is, right? I just resumed this this component, and in real time, it just gave me the difference. If that component was included, what would happen? How is it going to improve the design, right? Similarly, on the back end here, right? I have the tail, the trailer tail. Let me just resume that component, and you're able to see in real time the quickness with which you're able to see this, including updating the streamlines. Right, all these can be changed. You know, you can control the options here. You know, how to look at the streamlines, and everything can be changed here. But it's just to give you an idea of both internal and external flows. It's helpful. And if you had and the quickness with which you're able to make design changes, that's the key, right? The what if scenarios is what I kind of really like about this simulation live. So for example, if I go to one of these, it's an assembly that I've already set up. Just wanted to quickly highlight one thing here. I go to my simulate show results, and I could see the fluid flow. And if I look at my cutting plane, you know, you can look at it, right? We have done just similar to the last example. I've set up some velocity and some exits and entry exit parameters, and it's working. But what I could do as I'm seeing this direction field, or as I'm seeing, for example, the direction field and everything here. Okay, so maybe if I want to adjust this this inlet here, you know, to control the flow to the left, to the right, etc., I'm able to do that in quick time. For example, I could go to my assembly here, and let's see if I could go and change some dimensions real quick. I'm able to just go change this to just move it a wee bit here, right? And I do a Control G, regenerate in Creo. Immediately, can you see if I go to my cut plane and even the direction field? Now, as you can see, I'm seeing there in real time, you know, the effect of this is, you know, like the what if scenarios are so quick, right? That's also really nice, I think, where you can get this immediate feedback. And you may wish to make further changes to this, right? You might say, okay, so on this component, let me just stop the analysis here. I might want to go back and activate this part, and maybe I might want to, you know, create an extrude. For example, I might want to, let's see here, if I could just angle it a little bit here. So I'm just doing some angle, some surface there, so we could quickly do a replace, do a little surface. We'll just give it a specific depth in there, right? I just did it as a surface. Now I should be able to just go offset this guy, right? I should be able to use the offset with replace, right? I should be able to just say offset that, replace with this, and there it goes, right? I've done some changes. I don't know if the goal here is, as I do this, how is that going to affect my flow? I can go back. I'm in assembly mode, and I can just select this live simulation, and it gives me that immediate feedback again, right? So if I go back to my results, look at the cutting plane information here. So it does understand those surfaces there, and you know, the new change I did, everything in real time, right? Of course, I can I'll look at other things like my streamlines and particles, right? You can look at that, but the quickness with which you're able to do all this is huge, I think. And you're kind of leveraging, you know, the best of PTC Creo Parametric's, you know, proven design intent tools, modification, creation, editing tools, at the same time also leveraging ANSYS groundbreaking GPU technology, which is Discovery Live, that's working instead of Creo Parametric. So that's really what you're seeing here. So let me pause this here and then get back to my presentation here. So before we wrap up here, let me see. I want to just see if there's any questions in the questions area. Just go. Okay. So there's let's see. Let me see if there's any. Yeah, no questions at this point. I think. If you have any questions, feel free to. We'll just give everybody a minute here. If you have any questions, all our recordings, all our webinars, right, that we do at TriStar, we have it in our website at tristar.com, and they're also available in our YouTube channel, right? Please feel free to check them out. It might be some useful tips and tricks and what's new, some of the new technologies coming out. They'll all be available in our website as well as at tristar.com. And then, so let me we'll just see if there's any questions. Okay, looks like there are none at this point. Okay, so before we wrap up here, just wanted to remind all of you about this time-limited offer that they're running through end of this year. There's a 33% off on Creo Simulation Live and the new Creo ANSYS Simulation, which will be released in the newer date code of 7020 in November, as well as the advanced and basic extensions of Creo Simulate. If you are interested in these, please visit tristar.com or reach out to your reps to know more information about these TLOs. Okay, thanks again for joining. If you have any questions, we would like to hear from you. Please reach out to us at 800-800-1714 or visit tristar.com. Thanks again for spending this last hour with us. I hope it was useful and informative to know about Creo Simulation Live as to how it would help your current design process. So look, until we do a next webinar, thanks again for attending this. We look forward to hearing from you soon. Thanks for attending this webinar and see you soon. Have a great rest of the day. Thanks.